Hi there, here we are, section 6.4. We're looking at the empirical rule, which is on page 298. So we're going to be all normal curves all the time for a while. So the empirical rule covers normal curves. So let me see, here's the big challenge. Can I draw a normal curve for you? This is happening live, people. This is not the best normal curve you've ever seen. I don't like it that much, but I'll just go with it. So here's a normal curve. It's bell-shaped, it's roughly symmetric, and it has a mean and a standard deviation. So this is normal in theory, with a mean, that's a mu, and a standard deviation, sigma. So we say this x is normally distributed. This little squiggly means is distributed normally with a mean mu, standard deviation, sigma. Again, that's mu. So the empirical rule, so this is our mean right in the center. Nice little center. In theory, that's right in the center. That's mu. So the empirical rule tells us that 68% of the data, or the probability, is within one standard deviation. So suppose I can kind of eyeball this. I'm trying to eyeball it a little bit. I go out, so this distance right here is one standard deviation plus 1 sigma, and then I go back roughly the same distance. I'm trying to eyeball it so it looks about the same, and this distance is minus 1 sigma. So you go out either direction, 1 standard deviation, 1 sigma, and this whole area is 68%. So we also know from the empirical rule that 95% are within 2 standard deviations. So I look at this distance and I go out again. I'm trying to make it roughly the same because the standard deviation should be the same amount. So if I hop out that much, I hop out again. Then I hopped back, and I hop back again. Bop, 1 standard deviation. So this area here, all of this, 2 standard deviations, is 95% of the data. And so all this is 95%, and I will add one more. I'm going to change colors here. I'll make it yellow. So if we do one more standard deviation, hop. So we're near the end, and that's good because now I'm going to draw it up a little bit from here to here, and you can see this visually a little bit all the way from here. The entire area under the curve now, between there, this picture is really messy, all that is 99.7% of the data. And you can see it basically is all the data. 99.7%. So that's basically the empirical rule. It says 68% of the data are within 1 standard deviation, 95 are within 2, and 99.7, almost everybody, are within 3 standard deviations. That's what's so beautiful about the normal curve. Okay, that's fine and dandy. How do you use it to solve problems? So let me look at a problem here. This one, the empirical rule. On page 300, this is question 21. Assume that x is a random variable with mean mu and standard deviation sigma. And we want to find the probability that x is between 55 and 145. Okay, I'm going to draw a new picture. Hold on. Relate. So we know that x is normally distributed. So here's our normal curve. X is normally distributed. That little squiggle means is distributed as normal with mean 100 and then a comma. The next one means the standard deviation of 15. That's just the problem. I haven't really done anything yet. And we want to find the probability that x is between 55 and 145. We're going to use the empirical rule. So we want the probability, what is the probability that x is between 55 and 145? Technically it is less than or equal to the area of a line. Doesn't add up to anything, but I will not have you worry about that. So here's our normal curve. The center is right at 100. The mean is 100. That's the mean. So to do these problems, I notice, okay, this is how I do them. I know that I'm using the empirical rule, so I say, well, the standard deviation is 15, so I kind of hop out 1 standard deviation. Hop, 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 and then I hop each direction. This is me hopping. So there's 1 standard deviation. And in this case, I went out 15 in each direction. Where did the 15 come from? That's the standard deviation. So that number right there is 115, because I went out one standard deviation. This one is 85. You might wonder where I'm going with this, but I'm noticing that these numbers are multiples of the standard deviation. And I'm also noticing that this is in the empirical rule section. So do it again. So we go out another standard deviation. If you go out 15 again, you get 130. You go out 15 again, backwards that way, you get 70, because that's 85 minus 15, which is the standard deviation. So we're getting closer, but I want to be between 55 and 45, so I'm going to go out again. Okay? So again, plus 15. And that puts me up to 145. I saw that one coming, you guys. I saw that 45 is a multiple of 15 away from 100, which is the mean. And again, I subtract 15. So 70 minus 15 is 55. So now, because the problem says, what's the probability that x is between 55 and 145? So that is, let me see if I can fill this in a way that is satisfying. That's this whole area. Ding, that is sort of satisfying. See, between 55 and 145. So that's, that yellow area is what I'm looking for. 55 x less than or equal to. We will include the area of a line. So now we're using the empirical rule. I see that I am 1, 2, 3 standard deviations away from the mean. Again, I'll switch. So here's the mean. I go 1, 2, 3. 1, 2, 3. Oops. My hopping was bad. 1, 2, 3. There. So this is all 3 standard deviations. So you remember from the empirical rule that the answer must be 99.7% or approximately. So your answer here is, they might say approximately 0.997. Let's do one more hard one. This one's going to be so hard, you guys. Hold on. Hard one. So we're still on section 6.4, and x is a random variable with mean mu, standard deviation 15, sigma. 23 says find the probability that x is between 55 and 70. Ho ho. It's a little different. I could have used the same picture from before, but it was sort of messy. So this is the exact same scenario. X is normally, that's a weird looking squiggle, normally distributed with a mean of 100 and a standard deviation of 15. So you draw a picture like this. Your notes will be filled with weird little pictures. And we want the probability now that x is between 55 and I think it is 70. I will check. 55 and 70. Yep, 55 and 70. Okay, so we're going to use the empirical rule again. So we have 1, 2, 3 standard deviations here. We did this before. 1, 2, 3. Each little hop is 15. So that's 115, 130, and 145. And then hopping backwards, 1, 2, 3 standard deviations. I like to draw the lines, but they're not super mandatory. These pictures are not perfectly to scale, nor are my lines perfectly straight. So I'm going back. So back 15 is 85, back another 15 is 70, and back another 15 is 55. Okay, so now I am interested in, let's fill yellow. This is the area I want. Uh-oh. I just noticed that because I didn't, there, I'm going to have to fill it. I have to draw my line straight for my fill tool to work, otherwise it'll mess up everything. There. Whew, that's the probability I want. The probability that x is between 55 and 70. So now we're going to do a little bit of a cookie cutter thing. So the probability that x is between 55 all the way up. So we know there's 68% here, right? 68% here. I'll change colors. 95% here. 95% here. 95. You like that? 9. 55 all the way across. And blue, I guess, all the way from here, 55, all the way up to 145, represents 3 standard deviations, so the whole thing is 99.7. So all of this to here is 99.7. So this is sort of tricky, but look at this area here. Let me go back to red. This part here is 95. Everything in here is 95. That means these tail areas, both of them here, have to add up to 95. So what, like 100 minus 0.95 equals 0.05. So essentially there's 95% in the middle. That means there's 5% left for either tail. So there's 5% left on either tail. That means this tail here, boy, I'm gonna run out of colors. Pink. This tail, that whole area is half of 0.5, which is 0.025. And this whole tail, oh no, it's pink. Boy, the colors are sort of helpful, but they're sort of annoying. That area is also 0.025. Let me go over that again. The middle area here in red, this area is 2 standard deviations, so that's 0.95. Okay, so the pink areas have to be what's left over. So I took 95 out in the middle. That left 5% for both sides, so there's 0.25 on either side. This problem's kind of complicated. Okay, there's 0.25 on either side. So that would say that's our answer, but you'll notice the yellow area we want is like this pink area, but you have to chop off the other part. So now we have to do it again for blue, 99.7. 99.7 is this whole area. This whole part here is 0.997. If you subtract 1, then we can figure out how much area is on the tails. So 1 minus that is 0.003, leaving the tails, these tiny little things, let's make them purple. This part is half of that, 0.0015. It went to white again. I don't know why it did that. And this little tail is 0.0015. This picture is a mess. So, our answer, the probability that x is between 55 and 70, is this pink area, which is 0.25, right? What we want is the yellow area, and the answer is it's the pink area. Better go back to yellow. Okay, our yellow area is equal to this whole pink area, which is 0.025, minus that little area, which is 0.0015. What is that equal to? I get 0.0235. That one was way harder. Don't you think that one was harder? I thought that was harder, especially when you don't have beautiful paint to work with. But again, what you want to do is think about how much of the percentage is in the middle, and then how much does that leave for each tail, and then you have to divide the leftover percentage between the two tails, so you have half on either side. So again, when we took out 68% or 95%, it left 5% on either side. Divided by 2, we got the pink area, which was 0.025. When we took out 99% in the middle, that left 3% on either side. Divided that by 2, we got this little 0.005, and then subtracted that whole area minus the little area is 0.0235. Maybe your picture will make more sense. Maybe this was helpful. It was colorful. Will you at least grant me that this problem was colorful? Okay.